All right, pH for neutral. 7. pH for strong acids. Okay, 0 to 3, 1 to 3. Weak acids. 4 to 6. Weak bases. 8 to 10 or 8 to 11. Strong bases. 12 to 14 or 11 to 14. Arrhenius, definition of an acid. Produces hydrogen ions, which are H plus ions. Base, produce hydroxide ions, which are OH minus ions. Bronsted-Lowry, produce protons. And of course, a proton is a H plus ion. Since hydrogen just has a proton and an electron, when you get rid of the electron, all you got left's a proton. Bronsted-Lowry definition of base accepts protons. Formula for hydronium ion. H3O plus. Hydroxide, OH minus. If you know the pH, how do you determine the pOH?
pOH equals 14 minus pH.
That is correct. The two together equal 14. So the pH would be 14 subtract the pOH. If you know the pH, how do you determine the concentration? Now, if it's a whole number, then the concentration, basically you could just do that. So therefore, as example, if the pH were, say, 5, then the concentration would just be 10 to the minus 5. You'd be done. Now, if it's not a whole number, so for instance, if the pH was 5.3, well, the concentration would be 10 to the minus 5.3, which I don't know what that is, but you could use your calculator and use the button. And so, for example, okay, I'd have to use my second key, 10 to the negative 5.3, and it would give me that number, which would be the same as 5.01, 1, 2, 3, 4, 5, 10 to the minus 6. And so, again, using that 10 to the negative x button, I can get there. In this case, it would be 5.012 times 10 to the minus 6 by using that button. Okay, if you know the pH, how do you determine the concentration of hydroxide? Okay, that's right. Now again, whole numbers, that's easy. So let's say that the pH was 5. Then the pOH would be 9, which means then the hydroxide concentration would be 10 to the minus 9 m. If it was not a whole number, you would do the same thing. So for instance, if we're doing that 5.3 again, the pH equal to 5.3 means the pOH would be 8.7 14 subtract 5.3, which would mean then the concentration would be 10 to the negative 8.7. And again, using our calculator, negative 8.7 gives us that, which looks to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's basically 2 times 10 to the minus 9th m, as an example. Okay, if you know the concentration of hydrogen ions, how do you find the pH?
The negative number is the pH.
That's right. So for example, if I know my concentration of H plus equals, say, 10 to the minus 13 m, then the pH is just 13. Okay? Now, if it's not a whole number, like let's say that the concentration was equal to, I don't know, 1.8 times 10 to the minus 5. Let's say we had it like that instead. Then the way to find the pH would be to do the negative log of that concentration. Now that would also be true if it was a whole number. We could still do the negative log, but it's more work to do it that way. But if it's not a whole number, and so in this case, we just go log 1.8 negative 5. Now notice it came out a negative number. That's why we have that extra negative sign. So we would end up with a 4.7. It's always going to be a positive number. Okay, how do I know a salt?
That's a good question.
Well, let's make it easy. Acids, H in front. Okay, bases, OH at the end. So that gets rid of a whole bunch of different compounds right there. Now, what is a salt? Well, salts are ionic compounds, which means metals and nonmetals. Those are salts. Now, unfortunately, metals and nonmetals could be also a base, but if you go back to it's got an OH at the end, you can throw out the bases and then you're left with the salts. So like NaOH, that's a base. It's also looks like it might be Na, hey, that's a metal, OHs, those are nonmetals, but OH, base. Now, there's only a couple of bases that don't fit that, like ammonia, NH3, baking soda, NaHCO3. Other than that, you can pretty much go, hey, doesn't have H in front, doesn't have OH at the end. That's probably a salt. Okay, buffers. Anything that resists changes to pH. Most common buffers are made of both an acid and a base. Okay, how do you neutralize an acid? Add a base. How do you neutralize a base? Add an acid. Now, to be fair, if I want to completely neutralize the acid, I need a base of equal strength. If I want to completely neutralize the base, I need an acid of equal strength and the same amount. So, 20 milliliters of an acid that was, say, 5, I would need 20 milliliters of a base that would be 9, so that they would directly cancel out. Remember, get to 14. But in general, adding an acid to a base will neutralize some of it, at least make it weaker. Adding a base to an acid will neutralize the acid, make it weaker. What does neutralization mean? Okay, we cancel, basically, think of it this way, H plus OH minus makes water. And, of course, we also make a salt. Which, if we jump down to number 20, what new substance or substances? Salt and water. When we neutralize our acid or base. Okay, what is a conjugate acid-base pair? Give an example. If, for example, we said HCl and water, well, that would form H3O plus and Cl minus. Now, these always go in pairs. So the hydrogen acts as, or the HCl, that's the acid, it lost its hydrogen. The H2O acts as the base because it gained the hydrogen. So there's your pair. Okay, acid, base. In the other direction, we could say the same thing. This would be the conjugate acid because turning back into H2O loses the hydrogen. The Cl minus would be the conjugate base because it gained the hydrogen. So that's the way to look at it in terms of pairs. Okay? Any questions on that? Again, going this way, acid lost, gave away the hydrogen. The H2O, the base, the conjugate base, because it gained the hydrogen. And then in the other direction, this would be the conjugate acid because it lost, Cl minus gained. All right, equilibrium questions. Okay, if I increase A2, that means more A2, which means more collisions of A2 and B2. The more I got, the more collisions. Given the reaction, N2 plus 3H2 goes to 2NH3, and kilocalories or energy or heat, okay, by the way, that makes this exothermic. When equilibrium is reached, the rate of the forward reaction is equal to the rate of the reverse reaction. In other words, the N2 and 3H2s become NH3 at exactly the same rate that the NH3 turns back into the N2s and H2s. Given this reaction, N2 and 3H2 going to 2NH3 plus energy, again the kilocalories, energy, same thing. If the temperature is increased, okay, temperature is increased, pressure kept constant, how will the new equilibrium concentration of NH3 be affected? All right, increase in temperature means go away from the energy, which means shift left in this case, because the energy is on the right. Now, what does the shift left means? It means make more reactants which means less product. Well, the NH3 is a product, so we're going to have less NH3. When we shift left, more reactants, less product. Shift right, more product, less reactants. Okay, addition of a catalyst speeds them up. That's it. Doesn't change the concentration, but it speeds up the reaction rates equally. Okay, any questions on this side? Okay. What does adding a catalyst do to the activation energy? Lowers it or reduces it. Okay, what is activation energy? Energy needed to break bonds and allow the reaction to proceed in either direction. Okay? It's the amount of energy needed to break the bonds so that the reaction can take place. All right. Given this reaction, X plus Y makes Z and some heat, how will a change in Y affect the change in X? If we have a decrease in X, the Chateliers will want to make more X. More X means shift right. Okay, because more X, or excuse me, decrease in X, gosh darn it, got it backwards. It's always the opposite. Decrease in X means we want to make more X, so it shifts left. So that will make more Y. That's the key. Always go the opposite. So decrease in X means make more X, which means we need to shift left, which means we'll make more Y. Always the opposite. In a reversible reaction in terms of rates and concentrations, when is a chemical equilibrium obtained? When rates are equal and the concentrations are constant. Okay, what kind of change will not shift the point of equilibrium? Well, I have the same number of moles on the left, 1 and 1, as on the right, so changing pressure will not change the equilibrium. Because again, 1 plus 1 equals 2. If I increase the pressure, it would want to go to the side with fewer moles. Since the moles are equal, it's not going to change it. Also, adding a catalyst will not change the point of equilibrium. Okay, does an increase in temperature of a system favor the endothermic or exothermic? Okay, increase in temperature wants to go away from the heat side. In an exothermic reaction, the heat would be on the right. That would want to shift it to the left, which would be the endothermic side. But we call it exothermic because it's producing heat, so we would say it would favor the endothermic because we don't want to make more heat, we want to have less heat. Given the reaction CO and O2 makes 2 CO2, when the reaction is subjected to a stress, how will the concentrations of the reactants and products change? Now this is very vague, so you have to think in terms of what's the stress. Okay? So, any stress that shifts left for this reaction will increase reactants and it will decrease products. Shift right does the opposite. Now, what would shift right be? Well, for this equation, we do not have any temperature component, so we can't say anything about the temperature because we don't see heat or kilojoules or anything like that. But, for example, what about pressure? Okay, if I increase the pressure, it wants to go to the side with fewer moles. 2CO plus O2, that's 3 moles there, 2 on the right, so it would want to shift right. That would mean more CO2 and less of these guys, for example. If I did a shift left, how could I do a shift left? Well, adding CO2 would mean a shift left. That would make more of these guys and have less of the CO2. So that's how concentrations would change. Okay, 31. Given that reaction, what stress would cause the equilibrium to shift left? Adding NH3. Increasing temperature. Decreasing pressure would all make it shift left. Given A and B make AB, what change will shift it to the right? Increasing A2 or B2? Decreasing temperature. Those will all make it shift right. Because decreasing temperature means we want to go to the side with heat. Adding A or B means we want to get rid of some of the A or B. That would shift it to the right. Okay, given this reaction, which changes will not increase the concentration of NO? Okay, NO's on the left, so we need shift right. Okay, how do we get a shift right? We could increase H2. We could decrease N2O or H2O. We could decrease temperature, because decreased temperature we would want more kilojoules. Or we could increase pressure, because that would also go to the right. Okay, given x plus y goes to z and heat, what changes will increase the reaction of the products? The moles are the same, so pressure won't do it, but decrease temperature, make more heat, would make more product. Also increase x or y. And last one, if the pressure is increased, how will the concentration of NH3 change? Okay, there's more moles on the left, so increase in pressure will shift right, which means more NH3.